In this lesson, we're going to talk about recursive algorithms. So what is a recursive algorithm? You might be able to guess, and that is a recursive algorithm is an algorithm that calls itself. So this is a great example of a recursive algorithm here. In the blue box, you see it's an algorithm called factorial, and it takes an input, which is a non-negative integer n. And the output you see is going to be the the value of n factorial, and the name of this algorithm is factorial. But take a look at this and see if you see what's happening. So after we see the name of the algorithm and then what the input is, what the output is, then we see some statements here. So first of all, it says if n is equal to 0, return 1. Now, if you remember, for factorial, 0 factorial is indeed equal to 1. So they're saying if 0 is the number that is input for n, then just return 1. And that would give us the real factorial value. But now let's go on. If that's not the case, let's go on to the next statement that says r would equal. Then it says, now r is just something for, we'll see here, just kind of a temporary value that we're going to be using eventually to return the actual output. But we'll define r to be equal to factorial of n minus 1. Now this factorial, notice that's the name of this entire algorithm. So the algorithm is called factorial, and inside the algorithm, we're calling that algorithm again. We're saying do this for n minus 1 and put whatever you get for that into r. Then eventually, whatever you get, whatever gets returned for factorial n minus 1, notice in the return statement what it says. It says return r, what we just found, which is that factorial of n minus 1, times n. Now let's think about this for factorials. Note that like 7 factorial, that would equal 7 times, and remember it just goes down 6 times 5 times 4. But anyway, we could write 7 factorial as 7 times 6 factorial. 15 factorial would be 15 times 14 factorial, and n factorial in general would be n times n minus 1 factorial. So you see that here it is true that if we return the factorial of n minus 1 times n, indeed that is going to give us the factorial of n. Now the problem is that in order to find the factorial of n minus 1, we'll actually have to run this algorithm again. So it turns out that this recursive algorithm calls itself over and over and over just to get one particular value. Let's take a look at an example. Let's say that we put n equals 5. So it put 5 in for n. Then we're going to start with that first statement that says if n is equal to 0, return 1. But that's not the case. So then we see that r is equal to factorial of n minus 1. So, and then eventually then we see that we would return the 5 times 4 factorial. So you might think, okay, no big deal, I'll just find r factorial. But then we run this algorithm again to find 4 factorial, and it says, well, to find 4 factorial, we actually need to, we're going to take the 4 and multiply it by 3 factorial, because again, it's going to call the factorial algorithm again. But then when it tries to run the 3 factorial, it's going to say, well, to find 3 factorial, I need to go find 2 factorial, and then I'll multiply it by a 3 to get the 3 factorial. And then, but to find 2 factorial, I need to run the algorithm again. And then I would then take 2 times 1 factorial to give me the 2 factorial. But then I need to get 1 factorial. So 1 factorial is equal to 1 times, and then 1 minus 1 factorial, which is 0. Now finally, when we get down to this point, so at this point, nothing has been returned, but this algorithm has been called over and over and over again. It would be at this point that finally we get to use this statement that says if n is equal to 0, return 1. So finally, we could finally return something here at this point, and we could return a 1 for that 0 factorial. Now that that 0 factorial has been returned, then we can take that 1, put it in place of 0 factorial, and find what 1 factorial was. So it would be 1 times 1, which gives us 1. Now that we know what 1 factorial is, we could put that into our return for 2 factorial. So we'd put 2 factorial would be the 2 times the 1, and that gives us a 2. Now that we know what 2 factorial is, we put that in place of 2 factorial for the step where we were actually trying to find a 3 factorial. So we would put a 2 in there, get a 6. Now we know what 3 factorial is, so we can put that in place of 3 factorial here to find out what 4 factorial is. And then same thing, 4 factorial now we know is 24, so we put that into this original one that we started out with, where we were just trying to find 5 factorial, and we take 5 times what we found for 4 factorial, and that was 24. So we get 120, and therefore we finally get the answer 120. So if we find the factorial this way, using this algorithm, we see that we are calling it over and over and over, and we have to get all the way down to that n equals 0 in order for us to start returning things and then be able to eventually find the correct value for n factorial here. Here's another example of a recursive algorithm. It's a recursive algorithm to compute the power set of a set. So let's remind ourselves, I think you've probably learned about power sets in a previous class, but recall that a power set of a set A, so let's say we start with the set A, and if we're looking for the power set of A, we denote that as capital P of A. That is the set of all subsets of A. So we start with A, get all the set of all of the subsets, that would be considered the power set. So here we have over on the left this box, and it holds the algorithm called power set. And it's going to attempt to come up with the power set of any given set A. So the input is just going to be a set called A. The output is going to be the power set of A. So let's see what it does. We'll talk through it kind of in general first and then see an example. So first of all, it says if A is the empty set, return this set that includes the empty set. Remember, the power set is going to be a set itself, and inside that set is going to be all of the subsets. So the subset of empty set, remember, everything's always a subset of itself. So the subset, the empty set would be a subset of the empty set. So we will return the set that just includes the empty set. But if that's not the case, then we go on and we say, okay, so I've got this set A. I'm going to just take any old element out of A. subtract it out. Okay, so I have now a new set called A prime that has taken out one of my sets. I mean, one of my elements in the set. Then the next statement says set P equal to the power set of this A prime. Remember, A prime is something that we get once we take out one of the elements. But again here, just as we saw in the last example of an algorithm, it's calling itself because now it says find the power set of A prime. But that would mean going through this entire algorithm again for A prime. And so you see, then to do that though, you're going to again take out another element. And so we're going to keep taking out elements of A and keep calling it A prime until we get down to nothing left. And that's when we can finally return the empty set. But now let's look and see what happens on the other side of that power set. So this statement that says P equals power set of A prime, then let's kind of just talk through this and then we'll see an example. We're going to let P equal what we get back from returning that new call to power set. And then, so we're going to then come up with this new set called P prime that's equal to what we just got, what just got returned, okay? And then it says for each set in P prime, remember P and then P prime also, because we define P prime to be equal to P, is going to be, it's basically a set of a bunch of sets. So for each set in P prime, we add the A, the element that got taken out originally for that particular iteration, we add that back in to every set in P, which was the power set. And we do that for each set in P prime. This now might start to get fuzzy here, so now we'll look at an example. But after that is done, and those that element each time that got taken away gets put back into each of the sets in the power set, then we finally return eventually what ends up in P. Okay, so let's start here. Now this is straight out of the book, so you see that it looks familiar, this font here, but they're saying they want to find the power set of A, B, C. So the set, it's the set that we're starting out with is the set A, B, C. So A is an element, B is an element, C is an element, and that's the set. So that would be our A. Now we're trying to find the power set of that. So let's see if we can go through this a few times here until we get all the way down to the empty set. So the first thing we would do is call power set of ABC. So we'd go through here and see that, okay, we're supposed to, since it's not the empty set, we're supposed to remove an element from this. So let's remove the A. Okay, so we remove the element of A, and then we call power set again. So now we call power set on what's left. So now we're calling the power set of BC. So let's remove another element in BC. So let's remove the B. So we'll just now have C. So now we're going to call power set on our new set, which is now only including that one element called C. So then we have to remove an element from there. We get down to the empty set. So now we're finally at the very bottom calling power set on the empty set. So we look up here and see that if A is the empty set, return the set including just the empty set. So here down at the bottom on the right it says base case empty set return just this set of empty sets. So that's where we are now. We've finally gotten down to the empty set. But now, once we did that, we get to start returning things, and then we're going to start doing what's down here at the bottom of the algorithm once these returns start happening. So we first of all get this return of the empty set. So then let's look at these sections under, these statements under here. It says once something gets returned, you see where it says p prime equals p. So what gets returned is always just p. So first here we have p is the set of empty sets, but then it says let p prime equal that. So here I'm going to go ahead and let p prime equal what just got returned. Okay. Then it says for each set in p prime, then add what we get to p if we add the element that we just took away back in. So for this iteration, this last iteration, we took out the c. So we're going to add in, for every set in p prime, which is now is just the empty set, add in the c. So we add that to p. We add that to p. We add that to p. And so now p started out with just the empty set. Now we've included this extra here. Okay, now let's go on and say, well, what about the previous iteration? We're going to be returning this, what we see p over here on the right. And what do we do with it? Again, we go ahead and say p prime is equal to that. So just what got returned. But then for every set in p prime, we add what we had taken away for that iteration into it, and we add that back into p. So now p starts out with what just got returned, which is the empty set and the element c. But then for each of those, we're going to add in the b, which is what was taken away for that iteration. So we add b to the empty set, which gives us just the b, and we add b to the set c, which gives us the set cb. So that now is the p that we're going to return for that iteration. So now we return that p, and then for this next iteration, which was actually the very first time we called it, we are going to again let p prime equal what was returned. So p prime is equal to this set, the set of sets that was returned. And now we take every set in there and add what got taken away for that iteration, which was the element a. Add that into every set here in p prime and put that back into p. So for p, again, remember the first part of p here is just what it already was, what p already was. So those first four elements, that's what p was to begin with. But then we're going to look at p prime, add a into each of those sets. And then when we do that, those new sets then get added into p. So finally here, we have gone all the way up to our initial call of the power set within the power set, and then there's no more to do, so then it says to return p. So we would return this p, which is this set right here, and that would be the power set. Okay, here's another example of a recursive algorithm. This is an algorithm to reverse a string. So we're going to have an input of some string we're going to call S, and then the output should be the reverse of S. It should be putting it in the opposite, all the characters in the opposite order. So down here it says if S is the empty string, return S. So that's going to be where we finally get down to start returning things. But if that's not the case, if S is not the empty string, then we're going to pick out the first character in S. It says let C be the first character in S. That's the character on the left. Remove C, and then we're going to call this algorithm again for our new for what we get after we remove the C. So we remove that first character and then call reverse string again. And what comes out of that is going to be called S prime. And then after we would do all of that, if we finally get to the point where we're returning things, then the very last thing would be adding that one character that got taken out for that iteration, adding it back, but adding it to the end. And so once we are able to go through all the iterations and call that over and over and over, then whatever's left in S would be returned. So let's see this done with a simple string called POT. So we're starting out, our input is POT. And so we'll call this algorithm reverse string for POT. So we'll come down here and see that the first statement would say if S is the empty string, return S. But it's not, so we're going to go on down to the next statement. Let C be the first character in S. So that would be the P. And it says to remove that. So we're going to remove the P from the POT, and you see that we get OT. Okay, so we have OT. Then it says S prime equals what we get when we call this same algorithm on OT. So we call the algorithm again. So we do the same thing that we've already just done for OT, and that is removing the first character, which would in this case be the O. So now we're left with the T. Now we call reverse string on T, and we take out the first character and we end up with an empty string. So then we call this algorithm reverse string on the empty string. Finally, now we're able to return something because it says if S is the empty string, return S. So we're going to return S, which is the empty string, and so that would be S. But now, what do? We that the empty what we return is not S. As I said, it's what we get when we return something, and that's going to be S prime. So sorry, this is S prime. Now in the book, I'm just using their example, and all of a sudden they started calling this capital S, even though in the algorithm it's small s. So that's why you're going to see capital S here. But anyway, so where we're at is we've just passed in the empty string to reverse string and got something returned, which is the empty string. And again, you see over here on the left, we're supposed to call that, what gets returned, call that S prime. So S prime is now the empty string. But then it says the next thing we do is we add, we find a new string now that we're going to call S, which is what we get when we add whatever got taken away in that iteration back, but put it back at the end on the right. Okay, so this is the iteration, this is that last iteration where we took out the T. So we're going to put the T and add it to the end, which in this case would be the only thing in there since it was started out the empty set. But now we're going to call that S. S is what we get when we add that back to the end. Now we have S, and so we're going to now then be able to, that's what got returned. And so now we then are able to, since we returned the t in that particular time, then we can go on to think through the current iteration. So once we were able to return the t, then we would say that S prime is equal to what we get out of that. So S prime is what comes out of that iteration. And so then the next thing would be to add C, add what got taken out for that iteration to the end. So we would have TO because O got taken out of that iteration. And so we'll call that our new S. But then that gets returned, and then since TO gets returned, then we're going to call that S prime, and then for that iteration again we add what got taken away, which for that iteration was the P. We add that to the end and we end up with S, and that's TOP. So finally we've gotten down to returning all of the calls that we had made to this reverse string. And so now we're supposed to return S. So we would return S, which is TOP. And that's what would be the reverse string here. Now, you're not going to have to create algorithms like this, okay? What we're doing in this lesson is just learning about recursive algorithms, what they are, seeing some examples, and then kind of being able to go through here. So there'll be some participation exercises where they kind of have you kind of follow through this, and it's just for you to get the idea for these recursive algorithms. What you will be doing in the next lesson is being able to prove things about these algorithms. So we'll be doing mathematical induction again, but that won't be until the next lesson. So for this lesson, it's just a matter of seeing some examples of recursive algorithms, kind of following them as best we can, so that then later we'll be able to prove things about them. So for this lesson, again, there is just one additional exercise that would be good for you to look at. Again, it's the number 2, in this case from the recursive algorithms section. So that would give you some more practice. So you can take a look at that. It's not worth any points, but it would be good for practice. Then also for this lesson, there are participation exercises, but again, no challenge exercises. So you'll just have the participation exercises, and then go ahead and take a look at these additional exercises, this number 2. And I do have the solutions open for you so you can be able to go through and take a look at the solutions if you need help.